Hi there. This is a review of Unit 5, Momentum. What background information do you need to know? Okay, let's see. Change in momentum equals mass times change in velocity. Initial momentum can equal the final momentum, depending on the situation. We'll see. Okay, and the change in momentum equals impulse, which is J. Impulse equals force times change in time. So also you can do this. Set those two things equal to each other. There we go. And these are the same units, but this is the most common unit for momentum. All right. Let's see. A cart is moving on a track, and the velocities of the cart over time, frame of 16 seconds, is recorded on the graph below. So let's just take note of what we have here. We have v, we have t. What is the acceleration at 1 second, 8 seconds, 11 seconds? Well, I don't know why this question's on here. This doesn't really have to do with momentum, but whatever. Acceleration equals change in velocity over change in time. That's more of a kinematics topic. So all we have to do is look at, well, if we need v divided by t. So that means we look at the slopes. So 1 second. So at 1 second, which is about right here, what is the slope? All right, well, it goes up 2, it goes over 1. Yeah, up 2 over 1. So 2 meters per second squared is the acceleration there. The thing I'm looking at says something different, but that's what I see. So what about time equals 8 seconds? Right here, the slope is 0. So 0 meters per second. And 11 seconds. What about right here? Okay. That is like going down 2 over 1. So negative 2 meters per second squared. And how do we know that it's slope anyways? Well, slope is change in y over change in x. Y is v, x is t, so that makes sense. What's the distance that it travels? Well, distance is velocity times time. Just rearranging that velocity equals change in x over change in t. So you multiply these, that means you do area under the curve. So from 2 to 12 seconds. So this is 2, this is 12. We need to find the area right here. All right. We can split into these 3 shapes. All right, this one, that is 8 times 8, so 64. This is 2 times 4, which is 8. And this is 2 times 4, but divided by 2, so that's 4. 64 plus 4 plus 8 is 76 meters. All right, let me see what other ones we should do. All right, let's look at number 7 here. A 3 kg book. All right, let's write that down. Is traveling 1.5 meters per second. Okay, write that down. The coefficient of kinetic friction is 0.33. And the book moves a distance of 80 centimeters. Oh, thank you, College Board. That is not meters, is it? So we have to move the decimal to the left 3. 0.8. How did I know that? It's on the formula sheet. It will say 10 to the negative third. So you multiply 80 times 10 to the negative third to get that. It's on the back side. And the time is 1.6 seconds. It's obviously not the time for me to write this because this thing writes so slow. What is the change in momentum? All right. Well, how do we find change in momentum in the first place? Change in momentum equals mass times change in velocity. In other words, it is mass times final velocity minus initial velocity. So this would be the initial velocity because it's traveling at that. But how could we find the final velocity if we don't know if it doesn't tell us it? Well, we need to use kinematics to find it. So if it came, velocity we know equals x divided by t. And what was that? 0.8 divided by 1.6. And what is that? Let's see. .5 meters per second. All right, now let's plug that in. Mass 3, final velocity 0. I already forgot what it was, 5 minus 1.5. So the change in momentum is 0.5 minus 1.5 times 3. Hold on. That's not the answer that I see. Oh, that's actually, well, for this one, you wouldn't, there's friction present, so that's not what you would do. I apologize for that. Remember that that's not the only thing that change in momentum equals. I already said at the beginning. It also equals impulse, which is force times change in time. So the force, well, we have a frictional force. And what does the friction force equal? It equals mu mg in this case. If you don't understand that, just watch the dynamics video. So now we have this instead. So the way that I was doing it before, you could have done it, but this is a simpler way, in my opinion. I just didn't do it the right way with finding the initial velocity or the final velocity. All right. G 10. And then time is 1.6. So change in momentum is 15.84. And what's the unit? kg/m meters per second. All right. List something that must be true for momentum to be conserved in the collision. So how do we know? This is saying, because remember I said it can equal that. How do we know? Well, momentum would be conserved if it did equal that, but also it's got to be a closed system, meaning nothing else acts on the system, and it's got to be an isolate, or it could be an isolated system. Those really mean the same thing. So open and closed systems. Open system is when there can be other things acting upon it. So we have a box. So we have a box, and it's an open box. So pretend like that's a flaps on it. And we have rain. So if the system, if you're talking about the box system, it is open. And if it is the box rain system, it is closed. Because here's what it's like. So if it's just if the system only includes the box, are there other forces acting upon it? Yes, the rain force, because that adds mass to it. So that makes it open because there's another force on it, which is the rain. But if you include the rain into the system, then it's closed because the rain is within the system. So that's the difference. But that's how you would know. All right. Now we're going to do 2 more questions, number 13 and 14. All right. Number 13 is a little bit tricky. Let's see how we do it. Block A has a mass of 8 kilograms. Okay, let's write that on there. And it is released. At the bottom of the ramp, they collide in an inelastic way. That means they keep going in the same direction. They don't bounce off of each other. Block B has a mass of 10 kilograms. What is the final speed of both after they collide? How do we do this? How do we do this? So we can use the KFES method that I always say. So we need to write what we know. We did that. What we're trying to find, what are we trying to find? We're trying to find the final velocity. What equations can we use? Well, what do you usually do to find velocity at the bottom of a ramp? Well, usually we use kinetic energy equation. So we can use the kinetic energy equation to figure it out. But how do we figure out the kinetic energy? Well, we know that initial energy equals the final energy because it is frictionless. Said that. So it isn't important to underline key information. So the initial energy, because it's up on a ramp, it will start with UG energy and it will end with kinetic energy. That's just fine. This is just finding the velocity of the block A when it gets to here, but that's not what we're trying to find. We're trying to find when they get together, but let's start out by that. So the potential energy equals mgh, and kinetic energy, well, we're just trying to find the velocity. So if you rearrange that in terms of v, the m's would cancel out and you would get the square root of 2gh. Right? So if we're trying to find that, all right, oops, let's just do this. All right, 2, g is 10. Now what's h? Don't you dare say 4. No, no, no. That is not what you do, because the height is this thing. That's just the length of the ramp. And then you might say, oh, how do you do that? Well, you got to remember your geometry skills. You have an angle here, and in reference to that angle, this is the hypotenuse, and this is the opposite. We know what has sine, what has opposite and hypotenuse? Sine does. So sine of the angle, that's using SOHCAHTOA, sine of the angle equals the opposite over the hypotenuse, which is 4. So how do we find the O? Well, you would do proportions, and so that means you multiply them. So 4 times the sine of 45 is 2.83 meters. So that is your height. And when you plug that in, the velocity of A at the bottom is 7.52 meters per second. But that is not the speed at which they collide. That's just the speed of which it gets at the bottom. How do we, what do we use for collisions? We use momentum theorem. And we know that initial momentum equals final momentum. So we do mass 1, velocity 1, and since this is inelastic, they are together. So we do this, both masses added. Well, we're not going to do 1, we'll just do A because there's A. So we add the masses of A and B, and multiply that by the velocity of both, so we don't say A or B. I mean, we could just say VAB, but these are added only because it's inelastic, since they push together. If it was like, then they would be separate. And there is no initial velocity of B, so that's why we just only have this. So the mass of A was 8 kilograms. The velocity that we just found, that's why we did that, 7.52. And when you add the masses, that's 18, 10 plus 8. And then we're trying to find this. And when you solve for it, you find that it is 3.34 meters per second. So not really that hard, but you just have to think of the steps that you do. All right, final question. Now, this is kind of a weird problem. Just keep in mind I didn't make it. And this is more of like a, coherent paragraph response kind of question. So let's see. So what does it say? You have 2 balls of identical mass and size that behave very differently. Okay. You drop the so-called sad ball and it thuds on the floor and does not bounce back. Hang on a second. Wait, I can pause this. So sad ball, happy ball. You drop the so-called sad ball and it thuds on the floor and does not bounce back. I'm not going to drop down my desk because that will dent it. So I just put it on the floor like it actually said. You drop the so-called happy ball and it bounces back to almost the same height. Well, it didn't in my case, but whatever. So these are the same things. One doesn't bounce back and the other one does. Whatever. We can just skim, but now we're throwing it at a wooden block. So this is a metronome, but the sad ball. Wait, what does it say? The sad ball sticks to the wooden block, and that happy ball bounces off. Which of the following makes the wooden block have faster velocity? So that it's like a hanging wooden block. So which one makes it have faster velocity? That one, or don't want to mess that up. Okay. Explain using, and this is what you don't do. I hate you, acorn heads. No. You want to get a 5? Don't do that. All right. Well, we can type our response later on, but let's try to think. What affects velocity? What affects velocity? Well, if you're looking in terms of energy, we know that the velocity is square root of 2gh, which you would need to derive yourself. So let's see. Is g the same? Yes. Is h the same? Well, oh, wait, never mind. I was thinking of something different. Never mind. We're not looking at the height that it bounces, but we're looking, so what affects, we're thinking in terms of momentum. If we're thinking in terms of momentum, if you have a higher mass, there are inverse properties because, see, it equals this. So if mass goes up, velocity goes down. If mass goes down, velocity goes up. So they do the opposite thing of what the other thing does. So for the situation, so let's just say this is our block and this is the sad ball that sticks to it. But then there's the happy ball that bounces off of it. So what makes the thing have a greater velocity? Well, there is more mass in the end for that because the ball sticks to it. It has more mass of the system. So if mass goes up, velocity goes down. But for the other one, the mass is less because the ball bounces off of it. So the velocity goes up. So the answer is the happy ball. So how would you say that into words? Well, we can say because the sad ball adds mass to the system, the velocity of the wooden block is lower. Since the mass is less for the happy ball collision, the velocity increases. As evidenced by the equation, and in terms of energy, the happy ball conserves kinetic energy, and the sad ball does not. Because, and this is something that's just a general note, elastic Ke conserved, inelastic not conserved. That's something very important to know. I forgot to say that earlier. That should be on the background information. But that's how you would answer that problem. And as for what I've done for the other units, the thing that I didn't explain is this. An elastic kinetic energy conserved, inelastic not conserved. And the general momentum equation for finding like a specific mass or velocity, you would need to do this. M1 VO1 plus M2 VO2 equals M1 V1 final plus M2 V2. And obviously, if something was at rest, then it would be 0 at the beginning. And if it was the same, like the mass was combined, then it would have one velocity when it's inelastic. So that's it for this video. Thank you for watching.